Hi guys, today I'll be teaching you how to do number 17 in lesson 3.4. And so number 17, let's set it up, slide down. Yep, alright. So a scale is stuck to the ceiling, and a ball is thrown up into the air that collides into it. And so we want to draw a force diagram before it touches the scale, draw a force diagram when it does touch the scale, and what is the net force on the ball when it strikes the scale. And slide that up. Right, important equations, remember. In this case, Fg equals mg, right? And then m ball equals 1 kg. And then g equals, since we're on Earth, 10 newtons per kilogram. Right, to A. If you guys remember from the picture, the ball's not touching anything, so there's no F normal being applied to it. I also said that drag is negligible, and so that basically means there's no drag as far as we're concerned. And so the only force acting on it is the force of gravity, because the ball is an object that exists. So force of gravity equals 1 times 10 equals 10 newtons. And so your force diagram will be force of gravity equals 10 newtons. That's A. B. The ball still exists, so it's still going to have a force of gravity. And force of gravity, again, as we said, is going to be 10 newtons. However, we also collide with the scale. And so what that means is that there's a normal force being applied by the ball into the scale, and also by the scale into the ball, because Newton's law says that you have to have opposite forces. Right? And so what that means is that since the scale reads 40 newtons, that means the ball is pushing into it with a force of 40 newtons, which means that the scale is also going to be pushing back against it with a force of 40 newtons as well. So F norm, let's make that longer, equals 40 newtons. And then there's nothing from left to right. There's nothing pushing it upwards, so that's our whole force diagram. Lastly, C. What is the net force of the ball when it strikes the scale? In this case, F net equals F norm plus Fg, which is equal to 40 plus 10, which is equal to 50 newtons. And then technically you call it negative if they're both facing downwards, or since this one's calling for magnitude, you just leave it as 50 newtons. And that's how you just problem.